Okay, first I'm going to start with problem number 1, which was 6.5 times 0.13. Remember that when you're multiplying decimals, it's helpful if you line them up vertically. And I don't need to line up the decimals. Remember, that's just adding and subtracting where you need to line up the decimals. So then I need to do my multiplication from right to left. So I'm going to do 3 times 5 and get 15 and carry my 1. And then do 3 times 6 and get 18 plus 1 is 19. Add a 0 for a placeholder. Do 1 times 5 and get 5. And then 1 times 6 and get 6. So all I just did was I multiplied like there were no decimals there in the first place. I just kind of pretended those decimals weren't there. I added it all together. So I got 845. Then I had to count how many decimal points were in the original problem. So there was one number behind the decimal here and two numbers behind the decimal there, which meant that I needed a total of 3 numbers behind the decimal in my answer. So it's 0.845. And because it's a positive times a positive, it's just going to remain a positive. Number 2 now is going to be that division, 42.3 divided by -6. I'm going to rewrite the problem this way. And I need to start off by looking at 6 does not go into 4, but it does go into 42, and it goes into 42 7 times. I'm careful to make sure that I keep it lined up. The 7 needs to go over the 2 because 6 went into 42. I didn't have anything left over. I'm going to bring down that 3, but 6 doesn't go into 3 and come out to be a whole number. So I'm going to add a 0 because 6 goes into 3 0 times. But I can't have remainders when I'm doing decimals. So I'm going to add another 0 here because remember you can add as many zeros as you want to a decimal and it'll not change the value. Bring that 0 down. Now 6 will go into 30 5 times. 5 times 6 is 30. Now that we have no remainder, I know I'm finished. I'm going to shoot my decimal straight up here, so it's 7.05. And then because it was a positive 42 divided by a -6, my final quotient is -7.05. Okay, now for number 5, as you can see, I've already got it. I'm going to rewrite it, though, the long division way here. And as you'll probably recall, you cannot divide by a number that is not a whole number. So I'm going to move that decimal over one place to the right to turn that into a 13, which means I also have to move this decimal that's technically at the end of that number one place to the right. And I need to add a 0 as a placeholder. So now my decimal is right here at the end. So 13 goes into 78 6 times. 6 times 13 is 78, so I don't have a remainder, but I still need to account for this 0 right there. So 13 goes into 0 0 times. So now I'm finished. Remember, you need to line up your decimal right there, so I shoot it straight up. Because it's a whole number, it's going to end up right there at the end. We don't really need to write the decimal, so I can leave it as a 60. And because this was a negative number divided by a negative number, our final quotient is going to be positive, so that answer is just going to be a positive 60. Okay, with number 7, I am going to rewrite this multiplication problem so that it is vertical, just like I did before. With decimals, you don't have to worry about lining them up, and then I'm also just dumping that 0 for right now. I'm putting this, sorry, I got tongue-tied, in front of the 0.75 because why not? Who cares? I can just get rid of that. So now I'm going to multiply again, and I got to work my way from right to left. So 4 times 5 gives me 20. I'm going to carry my 2. 4 times 7 is 28, plus 2 is 30. Add a 0 for a placeholder. Now do 6 times 5 and get 30. Carry my 3. 6 times 7 is 42, plus 3 is 45. I'm going to add everything together, so all I did was treat that just like double-digit multiplication without accounting for the decimals. Now I got to account for the decimals. So here I have 2 numbers behind the decimal. Here I have 1 number behind the decimal for a total of 3 numbers behind the decimal, which means I need 3 numbers behind the decimal in my answer. So it's 4.800. And remember that when when zeros are behind the decimal, they really don't change anything. So I'm just going to get rid of those actually. So it's really just a 4.8. And then remember that our original problem was a positive number times a negative number. A positive times a negative is a negative. So our final answer is negative 4.08. Okay, next up, I've got a problem I need to rewrite here. So I'm going to rewrite it long division way. So negative 32.4 divided by positive 21.3. As you might recall, I need to move the decimal place over 1 to turn that into a whole number, which means I need to do the same thing over here. Now 213 will go into 324 once. I need to be careful about the way I've got my numbers lined up because since 213 goes into that entire number, 324, that 1 needs to be there over the 4. Then I need to go back and multiply. 1 times 213 is 213. I have a 111 as a remainder. Can't leave remainders with decimals, so I'm going to have to add a 0 here and then bring it down. 213 goes into 1,110 5 times. 5 times 213 is, let's see, 15, 6, 1,065. Then I'm going to subtract. So I have 45 left over. Then I got to add another 0 and then bring it down. So that's 450. 213 goes into 450 one time. 1 times 213. And oops, I'm kind of running out of room here a little bit. I'm going to move my work over here. If I subtract that 450 minus 213, I goofed. I should have said, oopsie. Should have said that 213 goes into 450 2 times. Sorry about that, guys, not just once. Okay, so 2 times 213 is 426. So now I've got a remainder of 24. I could add a 0 and see how many times 213 goes into 240, but thank the Lord, I'm saved by the fact that the directions say that I need to round to the nearest hundredth, and the decimal is right here because of course I'm just going to shoot it straight up for my original problem. And because 213 goes into 240 once, I can actually stop right here because it says to round to the nearest hundredth, which means I can stop right there at the second decimal place. And because it was a negative number originally divided by a positive number, my final quotient is a negative 1.52. And again, I stopped because I'm rounding it to the nearest hundredth, which is the second decimal place. Okay, 2/5 times 3/7. Fractions are the best because all you have to do is multiply straight across. 2 times 3 is 6. 5 times 7 is 35. There is no simplifying for us to do for this one. Okay, number 13, I've got a negative 2/3 multiplied by a negative 1/11. And again, I'm just going to multiply straight across. 2 times 1 is 2. 3 times 11 is 33. This was a negative number divided by another negative number. Negative times a negative is a positive. So my final answer is a positive 2/33. Number 15, these fractions are going a lot faster than those decimals were. So I've got 3.5 times 1.5. Remember that when you've got mixed numbers, they have to be turned into improper fractions in order to be able to multiply them. So this is going to become, so 3 times 2 is 6 plus 1, that becomes 7/2. 2 times 1 is 2 plus 1 is 3/2. So that is what they will be as improper fractions. Then I just multiply straight across. 7 times 3 is 21. 2 times 2 is 4. I'm not going to require you to turn it back into a mixed number because, again, in algebra, we have a tendency to use fractions a lot. So we're just going to leave it as 21/4, and it is already simplified. Number 17, we've got a 3 over 2 times a negative 1/3. Remember that you can simplify before you even start multiplying. And I know that right here in the numerator and the denominator, I have a 3. So I'm going to divide those both by 3. 3 divided by 1 is 3. 3 divided by 1 is 3. So now I just multiply straight across. 1 times 1 is 1. 2 times 1 is 2. And the problem was a positive 3/2 times a negative 1 over 3. So that is going to be a negative 1/2 for my final answer. Number 19, I have a negative 9 over 4 times a positive 1 over 18. I've got some cross simplification I can do again. 9 divided by 9 is 1. 18 divided by 9 is 2. So now I've just got 1 times 1 because I'm just multiplying straight across. 1 times 1 is 1. 4 times 2 is 8. Because this is a negative 1/4 times a positive 1 over 18, that is going to leave me with a negative 1 over 8. Next up is number 21. So I've got negative 30 over 11 times negative 1 over 3. I've got some simplification I can do first because 3 divided by 3 is 1. 30 divided by 3 is 10. Then I just multiply straight across. 10 times 1 is 10. 11 times 1 is 11. So I have 10 over 11. And it's a negative times a negative, which means I've got a positive for my final answer. Number 23, we have a negative 1/3 times a negative 7.5. Remember that you have to turn mixed numbers into improper fractions before you can multiply them. So 2 times 7 is 14 plus 1 is 15 over 2. I'm just going to leave that negative 1/3 the way it is. I've got some cross simplifying I can do. 3 divided by 3 is 1. 15 divided by 3 is 5. So now I'm just going to multiply straight across. 1 times 5 is 5. 1 times 2 is 2. It's a negative times a negative, which means that is going to stay a positive. 5 over 2. Okay, these next ones, these reciprocal questions, better be pretty straightforward for you. Okay, because we've got the for number 25, the reciprocal of 6 over 7, of course, is just 7 over 6. Sorry, I decided just to kind of do these all on the same page. Okay, so the reciprocal of 6 over 7, as we said a second ago, is just 7 over 6. Remember, reciprocal just means what you're getting when you flip it. The reciprocal of 14 over 23. Oh, actually, I'm sorry. The reciprocal of 1 over 22 is simply 22 over 41. This one would be negative 23 over 14. Just because you flip it doesn't mean that all of a sudden it turns from a positive to a negative or anything like that. Now for number 28, in order to find the reciprocal, you've got to turn it into an improper fraction first. So that is going to be 11 over 4, which means the reciprocal will be 4 over 11. Same thing for number 29. We have to turn it into an improper fraction first. So that'll be 16 over 3, well, a negative 16 over 3. So the reciprocal is going to be a negative 3 over 16. And then for number 30, again, I got to turn it into an improper fraction. So that's going to be 15 over 4. So the reciprocal is 4 over 15. Number 31, now we're dividing fractions. 2 over 3 divided by 1 over 3. Remember the expression, you keep it, so 2/3 stays the same. You change the division to multiplication, and then you flip or take the reciprocal of the 1 over 3, so that's 3 over 1. Keep, change, flip. I've got some simplifying I can do right here because 3 divided by 3 comes out to be the same thing. So then I'm just going to multiply straight across. 2 times 1 is 2, and 1 times 1 is 1, which simplifies to 2 for my final answer. Number 33, we've got 3 halves divided by 1/2. 3 halves stays the same. The division changes to multiplication. You flip the second. Again, I've got simplifying I can do ahead of time because you can divide those both by 2. 3 times 1 is 3. 1 times 1 is 1. That simplifies to a 3. For number 35, you've got a negative 9/10 divided by 3. First things first, we got to change that 3 into a fraction to take the reciprocal in the first place. That's 3/1. Then we keep, we change, we flip. 3 divided by 3 is 1. 9 divided by 3 is 3. 3 times 1 is 3. 10 times 1 is 10. That simplifies to or it doesn't simplify at all because it's already simplified. And then now it's time to take those signs into account again. We've got a negative 9/10 times a positive 3, which makes that quotient a negative 3/10. Okay, first things first, I've got to change that mixed number into an improper fraction. So 4 times 2 is 8 plus 1 is 9, so that's going to be 9/4. I'm going to change my division to multiplication, and I'm going to flip or take the reciprocal of the second one. 2 divided by 2 is 1. 4 divided by 2 is 2. So 9 times 1 is 9. 2 times 1 is 2. It's a simplified fraction, so I'm going to leave it as 9/2. Number 39, I've got 11/12 divided by 1 and 2/3. I have to change that 1 and 2/3 into an improper fraction first. So this 11/12 is going to stay the same here. This becomes 5/3. Then 11/12. Keep, change, and flip. I've got canceling that I can do here. 11 times 1 is 11. 4 times 5 is 20. And I still don't have any symbols to worry about or signs to worry about. They're all still positives. So I'm still left with a positive answer for my quotient. For number 41, now I've got a negative 1/3, and I'm dividing that by a negative 1 and 1/5. The first thing I'm going to do is change that second number into an improper fraction. 5 times 1 is 5, plus 1 is 6. So this is a negative 6/5. Second number is a negative 1/3. Or actually, the first number, I'm sorry, so it's just staying the same right now. So keep negative 1/3. Change the division to multiplication. Flip, now that's a 5/6. I do not have any canceling that I can do this time. So I'm just going to multiply straight across. 1 times 5 is 5. 3 times 6 is 18. And because it's a negative divided by a negative, that is going to be a positive 5/18 for my answer. Okay, number 43, it says a large piece of pizza has 12 slices. If Bobby ate 1/4 of the pizza, how many slices of pizza did he eat? Well, if he had those 12 slices, and of course 1/4 means that you took that pizza and you divided it by 4. So if there's 12 slices, if you split those 12 slices into into 4 groups to make a 4th, you're going to have 3 slices of pizza in each group. So the answer is 3. Last but not least, number 45 is kind of a doozy. Okay, so we've got this many yards, 131 3/4 yards of fabric. Each uniform requires 3 7/8. So it's asking how many band uniforms you can make. This is a division problem. So we've got to do 131 3/4, and then we're going to divide it by 3 7/8. I've got to turn them into improper fractions first. So if I do 4 times 131 and then add the 3, this comes out to be 527 over 4 divided by 31 over 8. Kind of a pain, I get it. Okay, so now we're going to keep, and I'm going to move this over to the side. I'm going to keep 527 over 4 the same. I'm going to change that division to multiplication, and I'm going to flip to 8 over 31. And that does give us some canceling that we can do, because 4 divided by 4 is 1, 8 divided by 4 is 2, and then 31 actually goes into 527 17 times. So I'm going to multiply straight across. So 17 times 2 is 34. 1 times 1 is 1. We can make 34 uniforms.